For decades, the Weldon Springs site in Missouri stood at the forefront of national defense. This is the story of the massive cleanup effort to transform the former defense site from this into this. In 1986, the U.S. Department of Energy began cleanup of the Weldon Springs site. The cleanup was called the Weldon Springs Site Remedial Action Project, or WSSRAP. It was the beginning of a monumental effort that took nearly 16 years to complete and cost almost $1 billion. WSSRAP focused on the contamination left behind from decades of ordnance works and uranium processing. The protection of human health and the environment was the key focus of the cleanup efforts. Once production was concluded at the site, chemicals were left behind in the buildings and other areas that required sampling, characterization, and consolidation before being treated and properly disposed of. The project required work to be done simultaneously at the chemical plant and a nearby quarry, which both contained chemical and radioactive contaminants. Water treatment facilities were constructed to treat the contaminated water at the quarry and chemical plant. Each batch of treated water was tested to ensure the water met permit requirements before being released. Team members removed infrastructure such as transformers, piping, asbestos, and other materials used to power the buildings and support production. Starting here made the rest of the work safer for the cleanup workers. With the infrastructure gone, teams undertook the task of dismantling and demolishing some 44 plant buildings, along with the efforts of removing bulk waste at the quarry area. Throughout the years of production work at the site, waste had been deposited into the quarry, resulting in debris, drummed and unconfined waste process equipment, and contaminated sludge and soil. Removing this waste required dewatering, draining water from the quarry and treating the water at the quarry water treatment plant. As the quarry water was drained and treated, the bulk waste was excavated and transported to the chemical plant for disposal. To help protect the local community and travelers, a dedicated haul road was built linking the quarry area to the chemical plant, allowing trucks to carry the material without accessing the nearby highway. As the final step in the bulk waste removal, the quarry was backfilled to prevent it from collecting surface water. Once contaminated materials were removed, work began on the residual chemicals left in the quarry area groundwater. At this location, intensive analysis and planning, including public and regulator input, led to a strategy of long-term monitoring and institutional controls put in place to prevent exposure to contaminated groundwater north of the nearby Femme Osage Slough and to protect the quality of the public water supply. As work at the chemical plant ramped up, workers tackled several issues, including removing contaminated soil, sludge, and sediment. Clearing contaminated soil proved to be a particular challenge, as several layers of soil and sediment had to be removed and stored for disposal. During the uranium processing years, a sludge-like waste product known as raffinate had been pumped into 4 holding pits. The raffinate was kept covered with water to prevent it from becoming an airborne hazard. Teams removed debris from the raffinate pits, and the remaining sludge was treated at a special plant built on site where it was used to form a grout. This grout was then pumped into the disposal cell, which was under construction at the time, where it solidified in the gaps between the solid waste already placed inside. Work on the disposal cell began in 1997 and would continue throughout the WSSRAP effort. The disposal cell would play a key role in the project's completion. Finished in 2001, the cell entombs and safely isolates contaminated material in a structure designed to last 1,000 years. The remedy selected for the chemical plant groundwater is known as monitored natural attenuation, allowing naturally occurring processes to reduce contaminant concentrations in the groundwater over time. Over the years, many groundwater monitoring wells were placed around the chemical plant and nearby areas to monitor the remedy's effectiveness and help measure naturally occurring processes. For nearly 4 decades, more than 5,000 workers championed the Weldon Springs Site Remedial Action Project, striving to clean up environmental contamination and ensure the long-term protection of public health and the environment. The Department of Energy's Office of Legacy Management remains a proud caretaker of the Weldon Springs site with a focus on long-term stewardship, community outreach, and site maintenance through monitoring and institutional controls. The Weldon Springs Site Interpretive Center offers a vital link between the past and the transformed site and demonstrates beneficial reuse, turning a formerly hazardous area into a positive resource for the local community. walking through the site's gardens, or enjoying the view from the top of the 75-foot disposal cell, it's easy to see the Weldon Springs site as a mission accomplished. The site stands as a beautiful example of beneficial reuse, the result of a massive cleanup effort to turn this into this.